Hello, today I'm going to start you off with my first video that's going to deal with Rstudio and ggplot2 visualization of our data. This is a cheat sheet that you are looking at here in front of you on your screen, and it's basically giving you all the tools that you will need to successfully work with ggplot2. ggplot2 will be your best friend in Rstudio when it comes to making figures. So today specifically, I'm going to be working with Geom Boxplot, the boxplot function here. Whoa. All right. Well, doesn't want to highlight correctly, but right here I'm hovering my cursor. I'm going to show you how to do Geom Boxplot, how to add the proper or my favorite color scheme, and a little bit of statistical analysis as well. So I'm going to quickly split over to Rstudio. Okay, so what we're doing here, let me just delete this so I can walk through it with you. Welcome to Rstudio. I'm guessing if you're watching this video, you already have it downloaded on your computer, which is great. I would highly encourage, though, if you're starting a new file, to do an Rmarkdown. Rmarkdowns are separated into subsequent groupings of your script that are denoted by these 3 tick marks, soft brackets, and then a description perhaps of what that section of code is doing for you. For instance, this whole one I called install packages. And these are the packages you ideally want to have installed to function in with ggplot2 and ways to manipulate your data. I'll just briefly go over the ones that I prefer having installed. So dplyr, it's one of the core packages of the tidyverse. It's extremely helpful for data frame manipulation. You have tidyr. It's used to help reshape data into tidy data that is easier to manipulate. Those two are very important regular ones that you should always have installed when using CSV files. The permute package helps with permutations. Lattice package aids in the graphics to provide better defaults to easily display multivariate relationships. All right, I myself am a soil microbial ecologist to be. I'm just a master's student right now studying soil microbial ecology, but the vegan package for all you community ecologists out there will be very helpful. Helps you with ordination and diversity analyses. Additionally, with that one, hand in hand, you have the govig package. Always install those together. Now, the one that you came here for today is the ggplot2 package. It's optimal package for creating excellent graphs and figures. I showed you the cheat sheet. I will have a link to many cheat sheets below in the description of this video. So if you are going to download those or want to see what other options there are, please click on that link. The tidyverse is kind of the umbrella parent package to ggplot2, dplyr, and tidyr, and many more different packages. These other packages are kind of underlying statistical importance for Gaussian linear and nonlinear mixed effects models, ordination, significance on your plots, and making them a bit more publishable. So those are maybe less descriptive for what you need right now, but I do encourage you to install those along with the other ones. Now that, let's say we've installed them, they're on the shelf. For instance, if this was a library, when you get a new book in the library, it's quote unquote installed onto the shelf, placed on the shelf. Well, we want to pull each of those packages off of our shelves for us to use, because we can't get that or use that information without having it in front of us. Hence the library function. Library function, you need to run it for all the packages you've installed. And once you do that, you can press this green play button to install your packages, and very quickly and subsequently use the library function, but since I've already installed them, I'm just going to show you here. You can highlight everything that you want to run, hit Control Enter, has that green line. And then down here on the bottom in the console, there were no errors. So everything's been successfully loaded and ready to use, hence in front of us. Now we want to import the file that we are going to use. Well, let's say I have a lot of files, which I do in other sorts of projects I'm working on. And I want to make sure it's a clean slate to work from, and I can not lose the newly uploaded or newly designated files amongst a bunch of others. Well, I want a clean slate, so I'm going to use this rm list equals ls. This removes all data from R, essentially giving you a clean slate. So if you look over here in the upper right, you see DN master data. That's a data sheet that I've uploaded previously, and I will be using it for this video. But let's say I had many more. I use this remove function, Control Enter, and the environment is empty. Now, since I'm going to be using that data sheet, I'm going to re-upload it. Your read CSV function is your best friend for uploading your files. So you'll use that, and then you'll designate the pathway to that file that you're uploading. This arrow function is the designated name that you've given it. I've named mine DN master data. You can name yours Matt's banana pie. It really can be anything you want. However, it's probably better that you make it a bit more descriptive to your specific project. Maybe abbreviations, etc. So also one last piece to note here, when you upload the direct file or the direct pathway, it often has the backslash function. You need them to have forward slashes for it to pull it into R. So let's upload this file. All right, I have DN master data. I have my sample ID for my given research, my treatments, and so on and so forth for a bunch of different measurements. It's my master data sheet. Today, we're going to look at treatment by pH. We're going to look at the variance of pH by my treatments in this particular study. Now, it's important that all of your variables in your CSV file are separated by underscores if you use multiple words to describe what's in the columns. Underscores make it much easier for R to understand and pull upon when you are manipulating your data and making figures. So now that I have my master data sheet uploaded, we're going to make our box plot, as I said we would today. Now, I'm going to show you what the end result of this box plot will look like. I Control Enter, and hey, look at that. We've got a box plot, nice axis size, and ANOVA. It's done our stats for us, and the color palette's easy on the eye. Well, how did I get to that point? Well, we got to start very simply. I'm going to walk you through this. ggplot. That's our function. Well, we need to upload our data, so you type data in. Any option that's given to you that you decide you're going to use, you can just hit tab. So data equals, hit tab, dn underscore. Well, there it is. It identified my master data, which has been uploaded previously. I'm going to call upon it. Well, there's a lot of data in that master data sheet, isn't there? I need to designate what I want to be on the X and Y axes of my plot. So I need to set the aesthetics, AES. The X in this instance, my X axis is going to be my treatment. And my Y axis is going to be my pH. Please note that capitalization matters in R. It will not understand what you're typing if you don't type it exactly as it's been inputted. It's a very helpful tool, Rstudio, but it is a dumb tool in the essence that you need to spoon feed it exactly what it needs to know to successfully make your plot. I will deal with the fill function after I come around to that section with my color palette. But for now, I'm just going to leave it with the treatment and pH. Well, I said I was going to do a box plot. Well, we need to add the box plot function. Anytime you add an element to a graph, you need to hit the plus, and I often separate it by a return. Geom is your go-to friendly option to choose the style of plot that you're going to use. Scroll through that if you're using it for the first time. You can do error bars, frequency, policy, density plots, count, bar plots, scatter plots, you name it. There's a lot, but today we're doing Geom underscore box plot. We're making a box plot. Now, let's say, okay, it works. That's all I wanted. Just wanted to see a treatment by pH. Cool. We got treatment by pH. Well, we don't have any stats, and it's kind of an ugly graph. How can I make it look better? Well, first of all, let's remove this ugly and distracting gray and white background. Because as scientists, we want to be able to focus on the data at hand and not distract from the points in front of us. So I'm going to add another element here. What's the theme of the plot? Theme underscore classic. Classic theme. All right, I pressed Control Enter. I'm running the plot again. It made the new one. That's a lot easier to the eye. This plot is now a lot more simple to look at, but we're still missing a couple different elements such as the color palette, and it's not the easiest to read what's on the axes. So we're gonna adjust that. All right. Now we're gonna add color. Scale, color. There's many different color palettes, but I implore you to use the Viridis package because that is a colorblind friendly package. And if you're trying to convey your research to a broad audience, you also need to think about some disadvantages people have. Try not to use red and green strictly. The Viridis color package is a predetermined color package that is helpful for colorblind individuals to be able to interpret your research. Now this says Viridis underscore C. That's a continuous. So if you're doing something with continuous data, go for that. But we are not. We're doing discrete because we have 4 discrete treatments. Underscore D is the one we're going to go with. Okay. Well, where's the color? We're going to go back a step. As I stated, I was going to hold off on the fill option. I have not designated to the plot style what I am necessarily providing color to. So let's add that element now. In our DN master data, the aesthetic of our plot is on the x-axis treatment, y-axis is based on pH. Fill. What are we filling these box plots with? Now, you can hit tab. That's just not what we're going to work with. It's not going to work that way. Just hit fill, ignore the option to hit tab, hit the equal sign, and then type in, since we're coloring by treatment, we're going to go with that. Now we're going to be able to have some color in our plot. Oh, look at that. Our legend even shows us the color of the box plot. It's in a nice color blind friendly palette, easy on the eye, no background, gray color. Cool. Well, we still don't have our ANOVA to compare the means or stats in general. And additionally, we haven't really enhanced the label size. Now, in order to increase the text on your axes, we got to go to the theme because we're working with the theme of the ggplot axis. Title X equals element text. Size equals, you could make it 456. That would be absurd, but we're just going to do 16. Axis, title Y, element text, size 16. Let's see how this goes. Did you notice that? These are now larger. pH and treatment increased in size. Awesome. But we still don't have our stats. Add another plus, adding another element, adding another element to it. So stat underscore compare, since we're comparing the means, which is essentially an ANOVA, we're using that function. There's other methods that you can use, but we're going to do an ANOVA in this one. So you need to put that in quotations so it knows the style of that method. And hey, right there, ANOVA p-value 0.76, which makes some sense to the eye. These box plots aren't very different. They overlap heavily. So it would make sense that our p-value would not be significant. Okay, now, what if you want to export this figure? Because you can right-click and copy the image, but I'll tell you right now, the resolution will not be great, and it won't blow up into something that's very readable when you're trying to publish. Well, you need to hit the plus, add one final layer. The file style is a PNG. You're making a PNG file. And then as we had imported our data, we need to find the same pathway, for instance. But this time we're basically exporting this figure. I did it up above, and you have to put it in quotations. And we're naming this one, for instance, because mine's pH and it's a box plot. See, that's very descriptive. And this is the pathway to where I can find that file. Like, as I said above, it's the pathway to where you're pulling the file, except this time we're exporting it. Now, when I run this again, you aren't going to see this table pop up below. It will be in that folder which you designated it to. Now it's sent off. And that's it. It's a lot of different miniature elements. Just imagine kind of, I won't call it a Russian doll, that's a bad analogy, but essentially you're just adding a bunch of layers. Let's say you were making a drawing with multiple colors on a blank sheet of paper. Well, are you going to start drawing with all the colors that you have at once? If you're going to make a good picture, probably not. You're going to use one color at a time or one element for the picture to meticulously piece together a very nice figure or a very nice drawing. You take your time with it. That's essentially what we're doing here. We're using this one large function that's ggplot, and then everything after that is under the umbrella of ggplot. They're just separate elements that are combined together in the way we've designated them to create the figure that I showed you before. I'm going to just comment that out to make my point clear. One last time. We've put this all together. We've run it. You've created this beautiful graph that is of a publishable form. So That's ggplot, boxplot with an ANOVA and a colorblind friendly color palette for you in a nutshell. So if you like this video, let me know. Please leave a comment. I am going to continue making these as I work through my own research. If there's any specific things that you are running into that are issues, leave a comment. I'll see what I can do. All right. Thank you.